Welcome to the Windows Performance Deep Dive channel. In this video, we deep dive into exposing network activity on your Windows device. So, whether you've downloaded a new app and want to see what servers it's talking to, or you're doing a compliance audit of network behavior, or you're determined to find out what code or feature is talking to that server halfway across the world, let's see how to do it. Here's an oversimplified overview of networking on Windows. Most applications communicate with the Internet via WinHTTP and/or WinINet APIs. Chrome, Edge, and some other browsers use the Chromium network stack. Ultimately, all Windows network activity goes through WinSock and TCP/IP. WinHTTP, WinINet, WinSock, and TCP/IP emit Windows ETW trace events which can be correlated for a unified view of network activity. Chromium also emits ETW trace events, but not in a way that can be easily correlated, so its activity is in a separate view. So, after cloning or unzipping the MSO-Scripts toolset, these three TraceNetwork commands will do the job: start, stop, and view. For the view command, do use the version in the beta subfolder. That gets you the WPA add-in which organizes everything. Like this. Here in WPA, we see a recently installed excel.exe doing gets and posts to numerous servers via 44 different URLs. Here's an actual demo. Run the PowerShell script, TraceNetwork start, then launch Excel and let it do its thing in the background. Then TraceNetwork stop. And in the beta folder, TraceNetwork view. The -fastsim switch speeds up symbol resolution in certain cases. Do look it up in the wiki. Soon WPA launches, giving us the netblame URL table. Netblame is the name of the add-in which gives us the network activity table and chart. Let's explore the information available here. First, we right-click on excel.exe to filter to selection. And there are the URLs. Then we can bring up the view editor with Control-E and turn on alternate DNS name, status, and geolocation. That mobile.events server on the bottom is also uksouth.cloudapp.azure.com. And sure enough, it's located in London, England. So let's see what code or component is posting 25K of data to a server in London, England. Most network activity happens on a thread pool or background thread. The netblame add-in stitches together the thread pool events leading to the network connection, sometimes linking the stack walks to as far back as WinMain, which is the application launch. Here in the view editor, we can see the option for a full stacks column, where all stack walks are stitched together. Instead, we'll go with the stack walks divided into 3 columns. First stack is closest to WinMain or application start. Last stack leads to the actual network event, and the middle stacks column is the aggregation of stack walks that ties them together. So the first stack is the main thread going from WinMain to create timer object, which posts the timer object to a thread pool thread. The middle stacks are from 2 Office thread pool threads. The top thread posts the work item to the bottom thread, which loads MSO-Aria. Then MSO-Aria creates a new dedicated thread. The last stack is the stack walk of that new thread which calls WinINet HTTP open request to connect with that server in London, England. I hope this video has given you an idea of what you can do with ETW and the TraceNetwork tool. You can find MSO-Scripts at github.com/Microsoft/MSO-Scripts. Do try it out and let us know what you find.